Welcome to the fourth chapter in our game design project where we're making an action RPG for Unity. And this begins the beginning of the end. We're going to start creating some interactable data so that we're able to keep persistence of different things like doors, switches, keys, objectives in between each map. Right now, we do actually have some form of persisting data, the player's health. So when I take some damage and I walk off the stage and then I return, I keep that same amount of health. But enemies respawn and, the world doesn't keep any sort of changes. And so the focus of a lot of these videos are going to be on actually making the encounters have some kind of memorable progression, like the game can remember what changes, the ability to keep monsters from respawning, or to have them respawn at specific times, and just kind of be able to string together things, switches, doors, keys, into a progression of events that can lead to a final encounter. In addition to a few extra things like different types of terrain to walk on, some puzzle type of encounters, so just different things to kind of extend upon our design. And so you can see that we have mostly fleshed out levels. We've got slimes that were set to super aggro, so they just immediately hunt me down. But yeah, so we've got a reasonably functional set of enemies. They work pretty well. The player works pretty well. The player will disappear when they run out of health. And that's where we left off. So this video's focus is going to be kind of setting up the infrastructure for keeping some kind of persistent data so that in future videos we can use all that. But first, let's jump to a little bit of code that we need to fix, specifically with the player fireball. As I was playtesting in between these videos, I did actually find a small, very small, and hard to reproduce glitch. And that's if the fireball hits two enemies simultaneously at rank 2, so this really only applies if you did the chargeable fireball, but it's still an error that can happen to a regular attack on this. If it hits two enemies simultaneously, it will explode twice. So on the on trigger enter 2D condition here, if we have are hitting an enemy and that enemy is not already hit, but let's add one more condition here of an impacts left is greater than 0. So meaning that there's still hits left in the fireball. That way it won't, if the fireball only has one impact, it won't double hit. Since those code does not run in parallel, one of them will run first. The other one will run on the same frame, but since impacts got decremented right here, shouldn't double hit. So make that quick change to prevent you from hitting two enemies simultaneously in the same frame. Like I said, it's really hard to reproduce, but slight little error there. Alright, so let's start kind of thinking about what we need. And what we need is some kind of way to keep more than just hit points across levels. We actually need kind of a system where I can kind of create variable names and then associate a state like true or false or a number with them. And so that's going to use a data structure called a dictionary in a C#. In Java, it's called a map. And so if you have familiarity with maps, it's kind of similar. So that means I'm going to create a new scriptable object right here. And it is going to need a C# script. And I'm going to call this data dictionary, if I can spell it correctly. And so I have my data dictionary.cs. Now this is going to be a scriptable object, so I'm going to pop over to int value and take some of these headers here so that I can have the menu asset and the correct inheritance. So I'm going to copy those. And I'm going to replace this, knowing that I'm going to have to restore this name here. So instead of int value, it's going to be data dictionary. Serialization callback receiver is mad. We just need to tell it to implement interface, and it will give us these two things. And we will not need the start or update methods here, so we're going to delete those. And so that is my start of this thing. So this is going to house, hang on. Just adding on my comment there. And so the data structure we want to use is called a dictionary. So kind of the idea behind this is we could have something like, there could be a lever, for instance, and we could say lever 1, and that string can associate to the Boolean true. Or maybe we could have a monster, or let's call it just orange blob 1, and that could be the string, and that could be associated to false, meaning it's not alive, or maybe it's dead, or however we want to kind of represent this data. Maybe it's true because true means defeated. Or we could do something like has upgraded fireball for the player, and that could be true, and then that could unlock our ability to have like a rank 3 fireball. So this dictionary, what it does is it associates a string with a Boolean variable, which is really kind of cool and flexible. It can actually be any associations. And so let's take a look at creating it. So public dictionary, and then angled brackets, string, comma, bool. I think you can look at the autocomplete inside of there. So you can see that the string is the key, which is the index essentially, and t value is the output. So it's kind of like creating an array where the strings are the indexes instead of numbers. And so we'll call it data Boolean. Because if we wanted to later on, we could expand this into having like numbers. So maybe you can keep track of how many fireball ranks the player has upgraded or something. A few notes about a dictionary though is, if you try to access an index that doesn't exist, you do get a error. And so when we actually access this, it'll be a little bit weirder than just accessing a array, although you can access it exactly like an array, and you'll see me do that in some of the code later. It's actually a really flexible data structure. All right, so on after deserialize, let's just have it blank it out. So data Boolean equals a new dictionary with a string comma bool, and then that. So it will clear it whenever this thing is unloaded from memory. So we're going to have to be careful to keep it in memory, which basically means every scene is going to need to reference this object. So something to keep in mind there. And one other useful method that we'll probably want to have, and it's going to be a static method called initialize check, and it will take in a data dictionary. And so the idea for this is any script that's going to interact with this data dictionary, we're going to need to make sure that it's not null first. So the functionality of this method is going to, we pass it in the data dictionary in question, and it's going to make sure that the stuff is instantiated before we try to access it. And if it's not instantiated, it will create it. Because we don't know necessarily when it will be created. So let's take a look. So first off, let's make sure that if data is null, we're just going to return false. And so what this is checking is, does the entire dictionary object even exist? If not, we're kind of in trouble. It should exist, but you never know. So I'm just going to return false in that case. And then we're going to check to see if data boolean, which is referring to this dictionary, if that is null, then we are going to create it. Data boolean equals new dictionary. So if it doesn't exist, we're going to make sure that it does exist. And then we'll return false, just so that the calling, wherever this was called from, it would know if it existed or not, and this will return true. And so that will guarantee, if I run this, if I run this inside of a start method, or really anywhere right before I use this dictionary, I can guarantee its existence, which will prevent crashing. So this initialize check method will be helpful, because it's going to prevent me from accessing null elements, which would be very bad. Well, I guess we need to fix this. It shouldn't be called integer value up here. It should be called data dictionary. All right. I suppose we could have made it more, I don't know. I didn't want to have to make a million separate little scriptable objects, so I did want to keep all my data in one place. All right, so this looks good. Nothing else we need to do with that. So let's minimize this, go back to Unity, and it's going to do that. All right, so next up is to start creating a game controller, so that data dictionary can sit inside the game controller forever, meaning as long as a scene has that game controller inside of it, this data dictionary will not unload, because when it unloads from memory, that's when it deletes all of the keys inside of it. So let's go and create a empty object here, and we'll call this game controller. Perhaps let's make that one word so it's consistent with the tag. Going to reset its transform. Its position honestly really doesn't matter. So maybe we'll set the Z, which means it's up towards the camera. X -5, Y -5. Again, it shouldn't really matter. Turn my gizmos on. Okay, so game controller is just chilling right there. Let's give it the tag, the built-in tag of game controller. And this is going to be an object that's going to house different things. It's going to house like my player health and mana, so that I can kind of keep track of a lot of these things and let them persist even if there's no player, for instance, in the level. Maybe we have a cutscene and we don't want to have a player object, but we don't want to unload the health, because if we unload the health, it resets back to the default. So to kind of keep this from dropping these variables, we will need another core script called game controller. C# script, game controller. And again, this game controller is going to have a lot of power. It's going to also be the thing that we can use to detect when the player is dead, or if a certain, like if we need to display you win. So it's going to have a lot of kind of responsibility, essentially. Okay, so now for its variables. So for the scriptable objects, we're going to need to have a data dictionary. We can just call it data. Make sure these are public. I guess that was a mistake I had made somewhere. Possibly somewhere. Well, perhaps I didn't. Or maybe it was something in the skeleton. Either way, I thought I had made a method. I didn't declare something in a method. But perhaps you would have found it at that point. Anyway, back to the game controller. So we want to have a scriptable object container for there. Another one, an int value. I haven't had one of these in a while. Player health. Player mana. And the other one was called a vector value. And player location. So that this script at least has all of these things, and we'll need to create a scriptable object for the new the new data dictionary. Other than that, right now it doesn't really need to have anything else inside of its start or update. I'll leave them there because I'll probably be coming back to this thing. Honestly, we're probably not going to want start. I think start's just going to get us in trouble. But update will be useful for detecting if the player has met certain conditions. So we'll hit save on this game controller. And I'm going to attach the game controller scripts to the game controller object. And you can see now it's got fields here. We need to make a new scriptable object for this data dictionary. So I'm going to create a new my scriptable objects data dictionary. I'm just going to call it data. And so inside of game controller, I'm going to bind all of these. Data goes in here. Player health goes to there. Player mana. And player starting location. So that this will then hold all of these scriptable objects no matter what scene we switch to. All right. And so that does also mean I should probably turn this into a prefab to make it a little bit quicker to build new scenes with. So I'm going to take the game controller and place it into the core prefabs. I'm going to save this scene, and then I'm going to go to all of my other scenes and drop in a game controller. So then I'll go to all of them. Now, it's going to be hard to really truly notice that any of this made a difference. We'll hit play, and nothing will have changed, except for the fact that we fixed that rare glitch in the fireball. We shouldn't be getting any errors, though. That's definitely a thing. We should not have any errors. And we now have this invisible game controller holding on to this data. That's going to become a big thing later on in this entire chapter. Is to be able to track that. Also, with having it inside of this game controller, other things can then grab the player's health or interact with the player's health if they need to. So the last thing is I did turn some of the art assets that we'll need for this chapter into a Unity package. So let's import that. Go to Assets, Import Custom Package, and it's called Top-Down 2D Interactables. So you can download that, and then we can import this. So we might need to go download that from wherever I've posted it. Hit Open. And you can see that it's going to try to load in an animation for some magic wall blue, some ice overlay, some levers, some kind of asteroid launchable, and some keyboard icons. And so stuff that's going to be useful as we do future things. So I hit Import. And we're going to revisit that in a future video. But for now, you can verify that we should have some kind of animation here under Environment, Magic Walls. We've got this blue sprite block looking thing. And that we have a whole bunch of things added to the textures, environment, interactable. We've got these levers. And so the levers, if you look, is a set of just different colored levers. I've named the blue ones and the red ones, so you can actually kind of see the naming scheme. I haven't named the other ones. You can do that if you wish. And then I've included these magic blocks, which I have renamed all of them, so that if you wanted to use something other than blue. And we're going to use those to kind of have a switch where you can turn off and on blocks to kind of make walls that you have to hit a switch to disable. And so we are going to see that in a future video. But right now, we should just be happy with the fact that we've got a dictionary, data dictionary set up. We've created the scriptable object for it, and we have created a game controller for it. And so we're going to pick up next video with persistence in monsters not respawning. And that will use this data dictionary that we just created. So I will see you next video.